right, so now that we have talked about what common differences are, first differences and second differences, now we're going to take a look at how do we build our functions from those sequences, once you know they're linear or quadratic. So before we start doing that, we're going to talk about what parameters are. We've been using these, but we haven't really talked about them as parameters. A parameter is a letter that represents a number that changes the orientation and position of your graph. So all of those numbers that we would look at to see how our graphs have changed from the parent graph, all those transformations, so shifting left and right, up and down, reflecting across the x or y axis, as well as stretching and compressing. Those are all parameters. So in a line, the parameters would be m and b, that's your slope and y-intercept. So that changes how steep your line is. And then in a quadratic, the a, b, and c, those are your parameters. And what a does is it opens up or down, which represents the reflection. Also, the number of a stretches or compresses your graph vertically. B is going to shift your graph left and right, but it's not a direct shift, so it's in conjunction with that negative b over 2a that we looked at before. And then C is also your y-intercept, which shows us your graph shifting up and down. All right, so let's take a look at an example here about linear function. And I know this is different from what you have in the notes, so find a place to write this down. I want to give you an example of how to build a linear function based off of a sequence because it's pretty easy. So the first thing we do is to list out all of these numbers. These are your outputs, which means that they are the y values. And these are all the y values starting when x is equal to 1. So if we have input, which is typically your x, we can list those off as 1, 2, 3, 4, 5. So that's always going to be the case. So when the sequence is generated for you, this is the sequence where y is, the first one is when x is equal to 1. And then this is when x is 2, x is 3, x is 4, and x is 5. So these are all the y values. So generating your first differences, you would subtract 4 minus 1 is 3, 7 minus 4 is 3, 10 minus 7 is 3, and 13 minus 10 is 3. All right, so they're all the same. They're all 3, which means it's linear. So now what do we do with this? So what you're going to do is kind of work backwards to get your y-intercept, so when this is 0. But we're also going to need our slope. And if you see here, our slope is actually our first difference. So y2 minus y1 over x2 minus x1. So all you're doing with your first differences is generating the slope of your line. So we know that m is 3. So to work backwards, what we're looking for is when the x is 0. And we know that this common difference should be 3. So you just have to ask yourself, what do you need to put here so that 1 minus this number is equal to 3? And so that would be negative 2. And so that means that your y-intercept is negative 2, or b is negative 2. Okay, so that is how to deal with it for a linear function. Let's take a look at quadratic. All right, so here's our sequence. I did give you a very easy one to start with, so maybe you already know what that is. I'm sure you do. But we're going to go through the process so you can see how to do it on an easy example and then be able to apply it to a harder one. So just like before, we're going to list out our outputs, which are these numbers, and then input. If you want to put them there, you can. If you don't need them, then you don't have to. Okay, so the first step is to generate your first differences. So you're going to take 4 minus 1, 9 minus 4, 16 minus 9, and 25 minus 16. And then since these were all different, we knew this, we expected it, we generate our second differences. So we subtract again, and we get 2. That's our common second difference. All right, so here are the steps. This is what we're going to do. First of all, we're going to let 2a equal the second difference. So whatever number you get here for your second difference, that is equal to 2 times a. So that allows you to solve for a. So we got our first parameter. A is equal to 1. So then we're going to work backwards to figure out the y-intercept, which remember that is c. So that means this right here has to be 0. This over here has to be 2. And now what would we have to put here? So 3 minus this number gives you 2. Well, it should be 1, right? And then you work over here and you say, well, what number has to go here? So 1 minus this is 1. So that should be 0. So what that means is this number right here is the y-intercept, because that's when x is 0. So c is 0. All right, so now with a and c, we can plug those in to our standard form, leaving the parameter for b in our equation. Because now, just like we've done with all our other problems before, we pick a point and plug in for y and x. And so I would say the easiest point to pick is this one right here. And you might be saying, oh, but 0 and 0 are easiest. But if you do that, then it gets rid of the b. So we definitely want to have something in there for x other than 1. So I'm going to choose 1, 1. So I'm going to replace x and y with 1 and solve it, and b comes out to be 0, as you, I'm sure, anticipated. So you plug it all in, and that means that the final solution is y equals x squared, which you already knew. Okay, so let's apply this now to a more complicated problem. Still easy, but it's just a little bit more complicated. It's not just y equals x squared. All right, so here are our numbers that are in the sequence, and I've already put in the inputs. And when we subtract, we get our first differences. And then we subtract again, and we get our second differences. So this time, second difference is -2. So, just like we did before, we set -2 equal to 2a and solve, so a is -1. Next thing we're going to do is to generate what our y-intercept is. So this is 0, this is -2. And then you have to ask yourself what goes here so that -2 minus this number gives you -2. So -2 minus 0 will give us -2. And then we do it again, so 4 minus what number gives you 0? Well, that'll be 4. And so that means 4 is the y-intercept, so that's c. So here's our equation, plugging everything in, leaving a b, because we need to solve for that. And then any of these points that you want to use, you can plug in here. So 1, 4, or 2, 2, or 3, -2. I'm going to choose 1, 4. So 4 and 1 gets plugged in, you simplify it all out, and you get a b equals 1. So that means that our final answer for our quadratic equation is y equals -x squared plus x plus 4. All right, I hope that that's been enough for you to understand how to do these problems. Good luck!